So the second part is on vector arithmetic. So if you remember, you have what we call your vectors to be quantities which has both magnitude and direction. You can only add up, also subtract vectors. Okay, the first one is the addition. So when you add two vectors, you simply add component per component. And the result is a geometric interpretation as follows. That is, when you add two vectors A and B, then we make use of your parallelogram law and come up with a vector A plus B. This one is the resulting vector. So A plus B, the vector A plus the vector B is simply you take its component, add it up component-wise. If you take the difference, or if you subtract two vectors, you subtract vector B from vector A, then again, component per component, and this will be the result. It may not be very clear to you na ganito siyang result. Tingnan natin ay itsura niya, ha? If you take a look, bakit naging ganun? Yung isa clear yun na sa addition. Pero sa subtraction, okay, kasi pag is your vector A, di ba ang vector B, ang negative ng vector B is the opposite direction. So making use again of your parallelogram law, this is your vector A minus vector B, and you make use of your parallelogram law, the resulting vector is this, A plus negative B. But this vector is actually equal to the vector na ito, di ba? Ganyan. This vector is the same as the vector here. Remember yung vectors na tinino natin kanina na mga equal vectors? That's why, take a look at this one. Okay, ito. Nandito yung A minus B. Because of that one. This vector can be put here. Equal lang sila yan. So we can move the vector representing A plus minus B to the position we got in the first figure. Okay. So what we have actually is your scalar multiplication here. Wherein, if you have a vector and you have a scalar quantity and you're asked to multiply it with that vector, then the result will simply be you multiply its component by this scalar quantity. So you will have C times A. The vector A will simply be C times A sub 1, C times A sub 2, C times A sub 3. So we multiply all the components by the constancy. What is the geometric interpretation of this one? If you have the vector A to be 2, 4, so what's 2, 4? This is your A vector. You move 2 units and then 4 units. So it's 2, this is 4 units. So this is your vector A. So what is the vector 3A? The vector 3A will now be, you multiply A by 3. So you will have from here, clear naman siguro niya, pero ito lang tanawon para mas so you will have your 3A is actually 3 times the vector 2, 4. But when you multiply that one, it will give you 6, that will give you 12. And 1/2, the vector A is actually 2, 4 here. So 1/2 times 2, that will give you 1. 1/2 times 4, that will give you 2. And negative 2 times the vector A, which is 2, 4, will give you again equal to, take a look, that's negative 4. This is negative 8. So it is represented by the following. It's a graphical representation. Your negative 1/2 A is 1/2 the magnitude of A, and it is supposed to be hindi pa yan negative, sorry. Positive yan siya. positive 1/2 A, ito, 1/2 A, is 1/2 the magnitude of A, it's also going the same direction as A. When you have 3A, it's 3 times the quantity A, direction as A. When you have 3A, it's 3 times the quantity A, and it's going to the same direction. But when you have negative 2A, then it's on the opposite direction, it is twice of A. So there are several nice applications of scalar multiplication. The first is what we call your parallel vectors. We say that vectors are parallel if there is a number C so that A is equal to C times B. Meaning to say, one is a scalar multiple of the other. Yun ang ibig sabihin ng equation na to. If you can express that vector as a scalar multiple of the other, then these two vectors are supposed to be parallel vectors. Parallel vectors. Hindi yan. So first example here is for determining whether vectors are parallel or not. If you take a look at vector A and vector B, notice that we can rewrite vector B as negative 3. This is a factor, scalar value with a vector A. Why? Then take a look. Diba, ang B is the same as negative 3 times vector A is 2, negative 4, and we have 1. It should give us negative, pasok na natin sa loob, no? Negative 6. Negative 3 times negative 4 will be positive 12. Negative 3 times 1 will be negative 3. Which is indeed your, ito, B. Okay lang? Nasundan?
Yes.
If they don't have, if you cannot express it as a scalar multiple of the other, then these vectors are not parallel. And an example of that is letter B. Find a unit vector that points in the same direction as you have the vector W. Again, you're asked to find a unit vector. If it's a unit vector, then we should have a magnitude equal to 1. You remember that? So earlier, we said that it is a unit vector if its magnitude is equal to 1. So how are we going to find a unit vector that points in the same direction as the vector negative 5 to 1? So first, we have to consider your magnitude. The magnitude of the original vector here, negative 5 to 1, is, we define again the magnitude. We find the magnitude as, yan, diba ang magnitude of W is equal to square root of A sub 1 squared plus A sub 2 squared plus A sub 3 squared. So A sub 1, we have 25. So that's actually square root of negative 5 squared plus 2 squared plus 1 squared. So negative 5, that's squared is 25. It's 4, that's 1. So that's 30 there. And the unit vector is defined as U1 over the magnitude of W times W, the vector W. So 1 over, you have square root of 30. Okay, the magnitude is square root of 30. The vector W is negative 5. Oops. 1, on ang microphone. So negative 5 over square root of 30, 2 over square root of 31. How do we know that this is indeed a unit vector that points to the same direction? You can actually take its magnitude again. So when you compute for the magnitude of that, you come up with the value equal to 1. So this vector u is vector negative 5 over square root of 30, 2 over square root of 30, 1 over square root of 30, points in the same direction as w, and it's only a scalar multiple of w. So what are your standard basis vectors? So if you remember, we have your vector A as A sub 1, A sub 2, A sub 3. Then this can be rewritten as A sub 1, 0, 0 plus 0, A sub 2, 0. Diba, component by component? So A sub 1 plus 0 will give you A sub 1. 0 plus A sub 2 will give you A sub 2. 0 plus A sub 3 will give you A sub 3. So when you add vectors, remember that you add component per component. So the vector A is the same as this one when you add this. Meaning to say, these three new vectors, which we call your standard basis vectors for 3D, can also be rewritten as A sub 1i plus A sub 2j plus A sub 3j. So any vector, if you have, for example, you have a vector, example, you have a vector 2, 3, negative 4. This is the same as, okay, that is the same as 2i plus 3j minus 4j. Because you can rewrite this vector a1, a2, a3, so 2, 3, negative 4, plus a sub 1i plus a sub 2j, lagyan natin ng arrow dito, plus a sub 3j. So you call that your standard basis vectors. So these two vectors can be written interchangeably. If you are asked to compute for 2a minus 3w, 2a minus 3w, we have 2, then a can be written as, the vector a is 3, negative 9, 1. This vector, negative I plus 8k, can be rewritten as negative, that is the same as this one. W is equal to negative 1. I is 0, correct? And ij, then k, so here you have 8. So negative 1, the numerical coefficient of negative I is negative 1. So numerical coefficient of j is 0, and the numerical coefficient of k is 8. That's why you have negative 1, 0, 8 here. So when you write that, because it's 2 times the vector like 3, negative 9, 1, and you have your negative 3w. So negative 3 minus 1, the vector negative 1, 0, 8. Come up with this vector. We have some properties of vectors. We have v plus w is the same, the vector v plus the vector w is the same as the vector w plus the vector v. If you add a 0 vector, it's the same as the original vector. You can actually distribute a scalar value to each of these vectors. So this is a distributive property. And we also have what we call your associative property. And we have your multiplicative identity 1. And we multiply to a vector. And distributive property can also be as follows: a times the vector v plus b times the vector v. So you have here a scalar value, and here you have a 2 scalars over your vector. So it can also be distributed. So we end up with following. I will not keep the annotations. So we're done with the second part.